Welcome to the Battery Testing Mentor podcast, a podcast about battery testing, battery handling, battery safety, and some more topics around batteries. I'm Johannes, and we are exploring here every 2 weeks another topic in this battery testing space. If you have any ideas and wishes about these topics that you want to hear, then please reach out to me, send me an email, reach me on LinkedIn or on any other channel. And I'm happy to take this into account. Also, if you want to get updates about the podcast, just sign up for the email update on www.batterytestingmentor.com. And with that, we can jump directly into today's topic. And that is not only a topic, but a guest. I'm very happy to welcome here Pablo Gutierrez Gonzalez, right?
Genau. Yeah, that's
I
right.
I only call you Pablo nowadays.
Yeah, it's completely understandable.
And my Spanish is not super.
Don't worry. Oh, good. Yeah, that's really right. Yeah, thanks for inviting me. I appreciate that.
Yeah, so Pablo and me, we know each other since quite a time now already. Some years. And you are very, very active in this whole eVTOL industry. And I mean,
That's right.
this made me consider, like already since quite some time, that would be a great topic to talk about, because it is really an fascinating area, and it's very different to these typical battery applications like electric vehicles, like stationary batteries and so on. So I'm happy that you found the time and came here.
Yeah, absolutely. I'm really happy to be here. Again, thanks for inviting me. And I think it's going to be a nice opportunity for us to discuss about it, to highlight a little bit the challenges in the industry and probably a common problems that we have had in the past.
Exactly.
Technically wise.
Yeah. Do you want to give a short introduction about yourself?
Yeah, absolutely. Yeah, so I'm originally a product design engineer. I studied in Colombia. I started my first master's in material science through a scholarship that I never finished, because the company that gave me the scholarship actually wanted me to work for them urgently on a project. Then I studied motorsports engineering at Oxford Brookes University in the UK. And after that, I tried to study a little bit more, but of course I got a little bit of too much of studying. I've been working in batteries since around 12 years, maybe 13 by now, of which I have been 7 years in the eVTOL industry. And it has been a challenge. It has been a roller coaster in the sense that things I don't know if it's in the case in automotive or other applications, but certainly when it comes to any challenge in aerospace, for me has been always that you see the tip of the iceberg, and then until you get into details, you realize, oh damn, what I've got into, right?
Yeah.
So yeah, I think it's a lot of details that I have in my career. I participated in the World Solar Challenge 2013 with the first my first team, or my first racing team in Colombia. Then I worked in companies in the heavy cargo handling industry, and in the eVTOL industry I worked in Volocopter as well as Lilium. In Lilium particularly twice. I think I came back after being at Volocopter, which was something a bit particular, but yeah, in Europe there was no much option to choose from.
But probably also interesting to see then the old workplace in a new light with this experience from a different
100%.
company.
100%. It's particularly, I think Lilium was a completely different company by the time I left the first time in 2020, and when I came back in 2024, we're two different companies. Certainly, the architecture was completely different.
And now you really spent a long time in this whole eVTOL industry, and also developed a lot of battery designs yourself. You were deeply involved in this development of these battery designs. Now, I mean, I guess especially because it's such a startup vibe, in the beginning you just develop a battery that this thing flies somehow.
Yeah.
and you don't care about anything else. You just
Yeah.
need to fly.
Yeah. That's true. I mean, the first time that I was at Lilium, there was not even regulation to design around for. So what we did is that, okay, what are the most basic concerns that we might have from a safety standpoint, from a let's say what is the physical limit of what the battery could deliver in terms of not only performance but also weight and to some extent costs. And yeah, we tried to come up with something quick to validate the technology, to have this initial approach of answering the question of, hey, is this possible? Do we have a business case here? And yeah, eventually that was the case. We did a prototype that flew nicely, and then we showed to some people, especially some investors of the company back then, that yeah, the company had potential, and we went through the process.
Yeah. So what is kind of the typical then requirements that come up? I mean, in the beginning you said, okay, you just see what are the real boundary conditions, what do you need to take care that basically it goes up in the air and comes down again. But when you then really go into a more kind of professionalized development process, let's call it, what are the typical boundaries that are really important in this aircraft industry? Like, if you broaden the view a little bit from eVTOL.
And that's a great question. So around 2020, I think, probably, the first SCVTOL, which stands for Special Condition Vertical Takeoff and Landing standard, came out. And so the way I see it is I mean, without trying to downgrade the effort of people that have worked in projects that actually fly like eVTOLs, but they have not followed the certification path. I think it's the way I like to call it is the difference between something that simply flies and something that has some at least initial basis of certification, at least to get what the so-called permit to fly, which is the first permit that you get from the regulator. For me, the difference between building a toy and building an actual product is completely different approach, and is what brings all the challenges into the game. I mean, just to give a little bit of context on that, but by the time I entered into Lilium the first time, there were some initial 3D drawings or 3D sketches, a little bit of testing here and there, but there was nothing really kind of solid. We developed the aircraft for around 1 year to 1 year and a half, almost from ground to the first flight. And I was like, oh, okay, this is not that hard, right? I had not had much experience in the aerospace sector, and I was like, yeah, this doesn't sound that bad. I don't know why people think that aerospace is such a complex field. But then we started getting a little bit more serious, developing a little bit the ecosystem of the certification together with EASA through a group that is called the EuroCAE. It's when I started realizing, okay, there is this other thing to consider, and this other, and so on and so on. And then you were piling up all of these guidance materials, certification bases, and so on. And then soon I understood how complex it was, and that was a complete life game changer for me when it comes to approach engineering in aerospace.
I guess the key considerations is always like this redundancy thought, right? Like you need to have this airplane flying whatever happens.
Yeah. You know, actually that's funny, because that makes me remember a story that recently happened to me. So after some time, so now Lilium is insolvent, right? So that's not a secret for anyone. But after the insolvency happened, I felt like to put some words into LinkedIn, right? Like the majority of people do. And I put the story of how nice the team was. The team was amazing, really nice synergy, really smart people, probably the best and most smart people that I have worked with, like except you, of course. And when I posted this this post, which basically included how nice the people was, but also that we were not purely naive or purely thinking about just how nice Lilium was, that were proper outstanding orders. We got to know the technology in certain level of depth, that what it was possible was not, and it was a matter of time until we got it sorted all out. And I remember this guy, actually was is a very well-known guy in the industry to some extent, without mentioning names though, but he mentioned, an aircraft of this size should be costing around 200 million to develop. Yeah, and me not feeling an expert in how much things were cost in terms of whole programs in aerospace, I asked, okay, how much does it cost to, or tell me which companies, in the eVTOL industry, have managed to bring type certification of a prototype or whatever concept with 200 million. Tell me those, because I don't know them. And it was an honest question. And the funny thing is, we continued to, he replied about something else, and at the end we didn't have I didn't get a clear reply. And I think is, probably he was not wrong, he just had he just had a different basis of what an aerospace program costs, because he thought, okay, what is the maximum takeoff weight of or the payload of this aircraft? And then he said, okay, what is a comparable aircraft cost, right, in terms of those? And when you think of other, I don't know, jets like, I don't know, Cessna or Cirrus or whatever, yeah, they cost around that amount of price, that amount of money. And I was like, okay, how funny it is that we might both be correct based on our individual point of view. So, and I started digging a little bit about what made Lilium so goddamn expensive. And it's not only Lilium. I mean, if you take a look at Archer, for example, Joby, Vertical Aerospace, all of them have spent insane amount of money. Volocopter themselves as well, probably some more than others, probably depending on how innovative their technology is, together with how aggressive they are pumping to get all the thing through. But what I found is that, and I had some sort of funny discussion with a friend of mine, and I find this word inside the eVTOL, which is not in other categories, such as CS23, which is basically the kind of category that he was talking to, which is normally used for utility aircrafts. And is fail-safe, right? We must be fail-safe, and we have to show 10 to the minus 9 catastrophic events, right? Which means that every 1 billion hour of flight can be catastrophic. If you do the math, 1 billion hours is...
It's a long time.
It's a really long time. So you have to have several aircraft for many, many years, and then you can have one catastrophic event. Yeah. And when you check those little things, which doesn't sound like much, but it means that you have to have dual or even triple redundancy a lot of systems. Lilium had 3 flight control computers, 10 batteries, 30 engines, right? Which means that we can have several failures all around, and the whole thing could have continued working normally. So, and you have to break down that into every single aspect, right? Like, you have to have 2 different codes, you have to have 2 different line of communications, you have to have 2 or even triple connection to every source of power and every source of consumption, location of consumption. So yeah, that's definitely a game changer.
Yeah. How do you test this? Because I mean, if you say one event in a billion hours is not something that you test batteries now, for example, for a billion hours, and then you find, okay, now we have it.
Yeah, those reliability numbers are crazy. That is probably one of the holy grails when it comes to battery testing. So we don't. There is a standard that is called the ARP 4761, And this standard helps us to do breakdowns of the safety aspects of the battery or systems in general. So in a battery, what you try to figure out is what is the failure rate and the failure conditions that are linked to it. So the way you do is that you consider failure rates, which actually you can either take them from other standards that have some definition of failure rates of either similar systems or similar components, or you just have that as a basis and then you validate later on. So what do you do is you lower this number down, right? Because if you have, you just need to ensure that you have 10 to the minus 9 at aircraft level, but you can fail a battery if you ensure that you can do what is the so-called TSFL, continued safe flight and landing. So if you have the same system in parallel, and meaning that you can fail one and then the other continue, then you lower that number, right? So you don't have to test that long, but it's still at the end is a lot of time. So at the very end, after you have reduced all of that testing, you have to do a little bit of brute force. I mean, you have to test several batteries at the same time, several cycles, and then build this reliability number, at least to get some statistical value in terms of interval of confidence and decent testing size.
So it's a lot of then also really working with the data. So the
working with the
testing
data,
doing statistical analysis, and
absolutely,
so on.
absolutely,
Yeah. Maybe also let's touch a little bit this typical design conditions that you have in the eVTOL industry. I mean, you say, okay, it must be redundant, it must be fail-safe. You need to have the whole aircraft must be designed in a way that it works under a lot of different conditions. But when we look now into the battery itself, what are the typical design conditions for on battery level then?
Well, that is normally broken down from above, right? So, as I said, you use this 4761 to define something that is called the design assurance level of the functions and of the items, right? That is called the FDAL or the IDAL. Based on that, you have certain functions and you need to ensure certain level of assurance or certain level of, okay, this cannot fail more than X amount of times. So once you have that, you know which functions are critical, and then based on that criticality, you know that there are certain components that cannot provide you that reliability, right? So what you do is that you either make that one function to be executed by two different or dissimilar components. So, for example, it's often the case that for example, when it comes to communication of voltage or temperature in a battery, what you do is that you do not only measure temperature via one channel, but you have two channels, and maybe in two softwares, and maybe even two computers sensing that signal. And for example, in terms of power distribution, if you have your power distribution linked to the battery, what you can do is that you have three different outlets or outputs of the power going through different sources, but on top of that you have a common bus bar that or a tie bus that basically connects the whole thing together in case this line fails and the other one can take over, and so on and so on. So yeah, you bring redundancy in the system itself. What I've seen mostly is redundancy in sensing. You need because sensing is the one that gives you the health indication, right? You could also bring redundancy when it comes to the thermal runaway protection. That of course has a different treatment, and probably the most important that has grown within me and among the designs that I've seen is the insulation. You normally with these systems you work at around 450 volts plus. Lilium was near 1000. You don't want to mess around with that voltage, right? You don't want to induce a voltage just because you want to save, I don't know, 30 grams, 50 grams of a foil that could have make a difference there. Yeah, so you don't want to mess around with insulation. That is for sure. Besides that, other redundancies that you can bring is Well, that depends on the environmental conditions that you're flying in. Of course, it's not the same flying in, I don't know, open space or in a, I don't know, over the water than flying over cities, for example. Those have different conditions. So, for example, if you fly over water, especially overseas, then you have a very salty environment, which can compromise connections over time. But if you fly over cities, then you might have a very highly polluted electromagnetic environment, which means that you have to make a good shielding of your equipment, because you don't want your I don't know, health indication or BMS or a state of charge indication of the battery to go nuts while you're flying, right? So you have to have proper provisions for those kind of things.
Yeah, really a lot of things to consider.
Certainly.
I mean, because if we then go even further, like to really these catastrophic events, or when really something happens, I mean, this is also an thing. I mean, basically, if you look at the normal car industry or electric vehicle, if the battery starts burning, okay, you have these 5 minutes or kind of a little bit of pre-warning is enough to brake and to park on the side of the road and just get out of the car and watch it burn in the worst case.
Yeah, just bring marshmallows.
Exactly. That's not really what happens when you're flying, right? You can't really park. Then
that is no option, and that is what changes probably in the biggest percentage the story of how to design airborne products. For designing to thermal runaway, you have to allow thermal runaway to happen, and not only happen, but to propagate. And even with propagation, you have to continue flying safely. Of course, under the assumption that you're not propagating more than one battery. That's when you have to have multiple batteries. But if you have one module or one cell burning or going into thermal runaway, you have to induce a propagation, which is part of the test that probably we'll have to talk later on, at the MOC, the so-called MOC3, or means of compliance number 3 from the eVTOL from EASA, and that is absolutely hard to design around. There are not many options, and probably the hardest thing is that it's not consistent. Every time that you test, your outcome is going to be different, even though you don't change anything. And probably you know more than anyone else that's the case. And
I mean, it's really these chemical reactions that happen in the cells are often so different, just based on some small different input, like different temperature of the core or something like this. And suddenly you have the different result. That was the first episode of the interview with Pablo. Super interesting in my point of view. In 2 weeks we will hear a lot more, so stay tuned and hear you next time here at the Battery Testing Mentor podcast.